Hello and welcome to another video. Today we'll be creating a three-tier architecture in Azure, focusing on availability and scalability. From the diagram you can see we'll be creating a front-end, back-end database using two availability zones with also a Linux front-end app and Linux back-end function app. Going to be utilizing Azure Load Balancer, storage account, key vault, in addition to two subnets, one for the front end and one for the back end, that can be used for both availability zones and a virtual network. This will have its own Azure resource with a front-end service plan, back-end service plan, database as previously mentioned, application insights, which is going to collect data from both the front-end app and the back-end app, which sends it to log analytics and the SQL database. I'll be using Terraform to configure all of this, and ultimately this is going to lead to an Azure website which is going to be sustainable, available and scalable. So let's get started on the Terraform code. Wait, before that, as you can see within the resources, all I have is a subscription. Nothing else has been created. We'll look at app registrations, nothing here. App services, nothing here. Be using key vaults as well, nothing here. Nothing in the virtual machines. So yeah, we don't have anything created in Azure, so let's skip over to Terraform and get started. First we'll create the provider file. The required providers. The version is going to be 4.0.1. We can also include the state file actually. So let's create a resource for that. Create a storage account first, and then we can store the state file in there. And then the name of it, we're gonna call it Oakland Storage Account for simplicity. Resource group _group name. We'll leave this for now. I haven't decided on the resource group name. We'll do location. I can actually create the variable file now, and then I'll fill it in. Need to do the account tier. That's going to be standard, and then the type is going to be LRS. Okay, great, that's done. Need a resource for storage container and provider. Let's do the provider first, and then subscription. Wow. And I needed to add the resource. Okay, yep, so storage container is going to be state, then reference it with storage state account that we just created. Resource is going to be group name, and location is going to be location. These are variables we're going to specify, and then provider will be Azure RM. I'm going to add the subscription after. So specify your own subscription ID here. I'm going to show you how you can get that once you have Azure CLI installed. So that should be, and yeah, once you've got that, you can add it to subscription ID. Saying something's wrong. I'm assuming it's the variables. So let's create those now. First variable is going to be resource group name. Yep, so it's going to be default name, which is Oakland Azure 1. I need to create a second variable, and this one's for location. and location description to be location variable. The default for it is going to be UK South. Okay, yeah, and now the errors have disappeared. We can also create the config TF variables, so we can also add the location here. Typically you should only need it here, but I think something with my configuration, it doesn't accept it from here, it accepts it from this variable, so that's something I'll look to improve in the future. Now we can create the main Terraform file. So resource should be Azure RM underscore resource group, and then we can name this one just RG, short for resource group. It's going to be variable location, tags. Yeah, so tags is going to be environment. Double check this. Okay, tags is optional. Okay, yep, so now that's done. Next we can start creating the app service plan and also the Azure website.tf. Okay, so now we're going to be creating these. Azure RM service plan, and then front end ASP, and let's also create the resource Azure RM backend Azure service plan, and then I'll just copy all the configurations. Okay, so yeah, that's created. So front end ASP prod, and the resource group name is going to be on the variable, no, it's on the resource that we created here. Yeah, which then links to the resource group name variable, and the location also links to the variable. I'm going to be using Linux, and stock keeping unit is going to be standard 1. That's for anybody in the free tier. Use standard 1. If you're using pay-as-you-go, you can use the premium app service plan, which helps you support the availability zone. So I've had to comment this out because yeah, on the free tier it won't run. And as your subnet, I'm gonna create a subnet for it as here. So it's gonna be a part of the subnet that I create in the VNet Terraform plan. And we can copy this here as it's going to be identical, and just backend and backend on its own VNet, because it's going to have a backend VNet, so I need to change that. This is for these. Okay, great. Now onto, I've actually saved this in the wrong place. That's not a problem. Now onto the website. Okay, so first going to create the front end. This is going to have the same variable location, resource name, resource group name, and service plan that we've already created. It's going to link to the front end one. I'm going to name it web at Terraform 2024, or TF for short. HTTPS only, yes. Site config TLS version 1.2. Again, this we can have it on false when using free or shared service plan, and the application stack for Node is going to be version 20 long-term support. Okay, now we're creating the app settings for the application insight. the instrumentation key, application insight. So it's going to connect to the application insights app. The profile is going to be version 1. Yep, so it helps to identify code that slowed down the web app, and the insight agent is going to collect telemetry. Currently keeping it at version 3. I think this is the latest version. This allows the web app to use other Azure services without needing to manage credentials. Okay, and that's the front end created. So now we can create the back end. So we're going to use the storage account for function app using the same resource name and a variable location. Account tier is going to be standard replication type. LRS is for locally redundant storage. So yeah, it copies your data 2 or 3 times within a local region. Yep, so now the storage account is done. Time for the Linux function at backend. Yep, so again, name, backend function app, resource group name and location from the variable storage account as just described above. Storage account access key, I'll create that in the key vault, and the backend is your service plan as referenced up here. So yeah, the app settings are going to be similar to the front end. And now site config, which allows a communication from the subnet. IP restriction priority is 100. Is subnet, as I said, is going to be created in VNet. The name is to make it clear that it only allows front end access only. Python 3.12 latest at the time. Identity type system assigned, just to make it clear that this has been assigned to the back end, and this depends on the storage account. And now for the VNet integration, so it's going to be virtual network Swift connection. The first one's going to be for the backend B, and second one's going to be for the front end VNet integration, app service. The subnet, I'm keeping this consistent, so when I create it I could just copy it from here, and this is going to depend on the Linux front end web app that we've also created. So let's create that VNet resource. Okay, so yeah, the virtual net or VNet is going to be named virtual net test with a private address space. Location is from the variable and resource name is from the variable. These variable here. And now to create the subnet. Yeah, so subnet's been created. The front end subnet specifically, address prefix .26, and the service endpoint is going to be Microsoft Web. So yeah, if it's not passed, then it gives Microsoft Web service endpoint not found on subnet. Delegation, and service delegation is going to be to the Microsoft farms or server farms. This one. No, there's one more. I think I've forgotten the life cycles. Let me add that. Yeah, so the life cycle. Okay, great. Need to create the backend subnet. So yeah, that's the front end subnet done. Time for this one. Yep, so similar to the front end, going to be called backend using the same variables. So resource name, resource group name, and location. Prefix is going to be different. The address prefix, this one's going to be .26, and it's going to be using the service endpoint of Microsoft SQL. Speaking of Microsoft SQL, let's move on to the database, which is going to be this part. So we've created the backend, function apps, storage accounts, subnets. So yeah, onto the SQL. Yeah, so creating a random password for complexity using special overrides and around 16 length characters. So for the MSQL server, naming it SQL DB prod, resource name, location as variables. The version is out of 2.0 and 12.0. Currently using 12.0, and the user is going to be user admin or the administrator login. The password is going to be randomly generated from the initial password resource we created. Azure Read Administrator is going to be Azure Admin, along with this object ID. Now we need to add the subnet backend VNet. Backend VNet SQL name, backend SQL VNet rule. Server ID is going to be from the SQL MSQL server we just created, and the subnet's from the subnet we created in the VNet, and it depends on the SQL server. And finally, the MSQL database. Next is going to be the key vault. So to use that, access from the configuration of Azure RM provider, and then the key vault here. Purge soft delete, okay, and then special permissions. Okay, so now there's your key vault's been created, enabled for disk encryption. Tenant ID should come from the client config, and yep, soft delete retention, so yeah, delete after 7 days or keep it for 7 days. Purge protection enabled, and kit unit standard. Okay, next is the key vault access policy. As I've added in a comment, is for service connection from app registrations to give this is given to store database secrets to key vault. Yeah, so key vault access policy, tenant ID again from client config. So key vault object ID, the key permissions is get list, and then the secret permissions, I've pretty much added all of them, and this depends on the key vault initially created. So yeah, the key vault access policy, this is for service connection from app registration. This is given to store database secrets to key vault. Tenant ID is from client config, and then the key vault ID is from the key vault. Key permissions is get list, and in secret permissions I've added most of them, and this depends on the key vault. Next is the permissions I'm going to give myself, and in addition to that, I've created a key vault access policy for the web app. Retrieved the managed identity principal ID or object ID. Yep, so this can be received from when the web app is launched, and I've also created monitor diagnostics or log diagnostics. It's going to be enabled for audit event, all metrics, and it's going to the storage account. So yeah, now to confirm, key vault created, storage account, application insights, log analytics, front end service plan, back end service plan, SQL subnets, and both of these. Oh, and the virtual network within the resource. Okay, so next is going to be the login file with log analytics workspace. Yep, so log analytics workspace and application insights. It's going to be the application insights from the front end web app, and it's going to be pretty much everything GBU 2018, and the retention is going to be 30 days. Next, we just have to create the outputs Terraform file. So now within the outputs, we have the output for the resource group ID, the front end URL, which is going to be the Linux web app front end app name, going to azurewebsites.net, which we will be able to access or put anything on as well. Backend URL is going to be for the backend Linux function app and the backend function app name, and Azure Websites for the URL, azurewebsites.net. Instrumentation key for the application insights, sensitivity is going to be true, and app ID for application insights as well, sensitivity is true. Now that that's done, we can disable Terraform initialize. Right, great, that's done. Now let's Terraform plan first. Change that. Alright, let's try that again. Okay, so it read the client config. It's going to add around 24 resources, virtual net, integration for front end and back end, Vault, access policy for the app and for myself, Linux, web app, back end function, front end web app, log analytics, diagnostics, database. You should be able to see all the same, so you can go into it as well when you've created it. So let's apply this. Okay, that's interesting. Performing, create unexpected resource group. Oakland Azure 1 could not be found. I think most other things have loaded. So one thing you can do with this is you can create it within the Azure console and then bring it in to be managed by Terraform. So let me show you. Wait a minute. It's here. How could you not find it? Am I misreading it? Provide 11 resource group name, Oakland 1, storage account name, Oakland storage account, performing create exotic 404 error, not found with Azure. Oakland Azure 1 could not be found. Variable Oakland Azure 1. That's a bit of a weird error. It's there, so I actually don't need to create it within Terraform, within Azure, because the storage account for the web apps are here. Okay, I think it's just the state file storage then. Yeah, for state account. Okay. Yep, so we can see the rest of has been created. The backend service plan, function app, front end service plan, application insights, SQL databases, log analytics, and app service. So we can access this through the URL. Okay, yep, so app service plan is ready and up. Might just be best if I find it through here. That front end. So yep, here's the domain for it. Yep, so web app is running, up and running, waiting for me to build things on it. So I could build not just Node.js but other things, but this is just to create the sort of architecture around it. If that's something you want to see, let me know. Now that that's done, we can Terraform destroy. and thank you for watching. See you in the next video.